So quotient rule for differentiation. If f and g are both differentiable, if their derivatives exist, then how do I find the derivative of f divided by g, right? Quotient means division. Division. Okay, so it's a surprising formula. Let's write it down and then figure out how to remember it. G of x, so it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared, the denominator times itself. Okay, so it has there's a nice little song that can go with it. If I think of the denominator being low and the numerator being high, then here's a nice little song. It's low, d high, derivative of high, minus high, d low, derivative of the denominator, all over low squared, low times itself. So that little song, if it's helpful to you, low, d for derivative, d high, minus high for numerator, d low, derivative of the denominator, all over low squared. Low squared. Right? Maybe I can write all over. Divided by, right? All over low squared. Okay. Low, d high, minus high, d low, all divided by low squared. Low, I think I'll even highlight that. Squared times itself. Okay? This printed a little strange, sorry about that, but it's still readable. Differentiate h of x. First, we want to see that h is a quotient. H of x is one function of x divided by another function of x. So we need to use quotient rule here. I think we should do a little bit of scratch. With a lot of practice, you will just jump in, but let's do some scratch work. Okay, so my low function, my denominator function, and my numerator function we need. Low. I'm going to start with the denominator just because this thing starts with low, right? It starts with the denominator. G of x is 5x squared plus 2. I'm going to need g prime of x, so let's do that. G of x is a polynomial. It's a function of x plus another function of x. I can differentiate term by term. The derivative of 5x squared is 5 times 2 times x to the power of 2 minus 1, x to the 1, plus the derivative of 2, and the derivative of a constant is just 0. G prime of x is 10x. So we have our low, and we have our d low. Okay. High, my numerator function. Let's see if we can, there we go. My numerator function is 4x cubed minus 7x. We're going to need the derivative of that, f prime of x. We've got a polynomial. We've got one function of x minus another. I get to differentiate term by term. Just thinking about the derivative of 4x cubed, that gives me 4 times 3 times x to the 3 minus 1 power, x to the power of 2, minus the derivative of 7x is just 7. The slope of the line y equals 7x is just 7. And there we have it. 4 times 3 is 12 times x squared minus 7. So now I have my high and I have my d high. So now it's time to just stitch this all together and clean up a little bit of the algebra, and we are done. Okay. So h prime is low. There we go, just look at that. It's g of x. It's 5x squared plus 2. D high, derivative of your numerator, 12x squared minus 7, minus high, my numerator function, 4x cubed minus 7x. D low, derivative of my denominator function, is 10x. All over my denominator function times itself. All over low squared. Okay. Do not say I see a blue in the top and a blue in the bottom. I can get rid of one of them. There is a subtraction sign here, right? I can only get rid of common factors. I can only acknowledge a secret times 1. So don't make that algebra mistake. Technically this is done, but let's go ahead and clean it up. I'm just going to FOIL this out, distribute this, subtract that whole thing, distributing the negative, and just see if my numerator is factorable, and if not, just leave it as it is. All right, so 5x squared times 12x squared. 5 times 12 is 60. X squared times x squared is x to the 4th. 5x squared times a minus 7 will be a minus 35x squared. Let me give myself a little more space. And 2 times 12x squared is going to be 24x squared. 2 times a minus 7 is minus 14. Subtract. See if you pick up the mistake I'm about to do here. 10x times 4x cubed will be 40x to the 4th. And 10x times a minus 7x would be a minus 70x squared. Did you see my mistake? All over denominator squared. I am subtracting this whole product. That product has two terms. I need to subtract each one. I need to distribute that negative. Right? Just leave your denominator factored. Why do I say that? Fractions are in simplest form when there are no common factors in the numerator and the denominator. No secret times ones. So having the denominator already factored is delightful. Leave that alone. Right? So here, let's just distribute that negative and combine some like terms. How about we do that a little bit along the way? Minus 35 plus 24 is minus 11x squared minus 14. And now here distributing that negative, we'll have minus 40x to the fourth plus 70x squared all over my denominator. Low squared. And we've got a few like terms here. Almost done. 60x to the fourth minus 40x to the fourth is 20 of those things. 20x to the fourth. And then we've got minus 11 plus 70 gives me my 59 x squared minus 14 all over my denominator squared. My numerator is not factorable, but if it were, it would be good to factor it and see if there's a common factor in the numerator and the denominator so you can remove that secret times 1. Okay? So now when you see one function divided by another, like we did here, we have yellow divided by blue, you want to say, I'm going to use quotient rule and go after each part and then stitch it all together. Quotient rule has more opportunities to make a mistake than product rule, right? Because order matters in subtraction, right? It has to be GF prime. It can't start with FG prime. Product rule didn't have that issue because order doesn't matter in addition or multiplication for that order. This one's a little less likely to make a mistake. Okay. Thank you so much for watching our Intro to Derivative Rules videos here, and I look forward to working with you next time.